All right, today is February 12th, and this is ITS148, and we are still in Chapter 7, where we're talking about exception handling and data validation. And we went over the slides. We completed the slides last Thursday, and so today I guess I'll quickly review the slides again to make sure we got everything, and I guess I'll probably go over the assignment. And it's a pretty straightforward assignment this time. It's stuff that you learned in ITS148, so it should be pretty straightforward. So let me share my screen. All right, there we are. And I think I can move this over so I'm not boring you. And let me get rid of this. All right, so let's look at the slides, and we went over these last time pretty good. Exception handling, hierarchy of exceptions. This is what happens when the program bombs, and it gives you, when the program bombs, you get the type of exception is right up here at the top. Format exception, you call it that. You can address it that way. It says it gives some ideas of how. It says the input string was not in a correct format, so obviously somebody was trying to type something into this TXT monthly investment. By the way, I just figured out that watching my videos last time that you can't see my mouse when I'm doing this. So let me try to do something else so you can see my mouse. Slideshow. Let me, oops, try slideshow again. And let me swap this. All right, here we go. And let me grab a pen. How to handle exceptions. We went over this. Here we go. So somebody obviously tried to type something in here, and then your program tried to convert whatever they typed in into a decimal number and store it into this variable, and it was not successful. A format exception was thrown, as they say, and it was unhandled. You didn't have a try catch there to try to handle it. This is the name of the exception, and further information is the input string was not in the correct format. And this gives you some ideas of what could have, of why it could have happened. And so that's an unhandled exception. And this reviews the hierarchy of these exceptions. We have exceptions here, and we can have format exceptions, which are pretty simple. Those are usually discovered by what's called the C# runtime machine. It's still a bunch of software that's running. The other kinds of exceptions, we usually sort of categorize them this way, are arithmetic exceptions, and those are often detected by the microprocessor itself. The microprocessor doesn't let you do things like divide by 0, or the microprocessor doesn't let you try to stuff numbers that are too big into variables. You might have a variable that can only hold up to whatever 2 to the 32nd power is, or 2 to the 31st power for a regular integer, and you might be adding up a bunch of numbers or multiplying a bunch of numbers, a bunch of integers, and you might end up with a result that's bigger than that number. That exception would be detected by the microprocessor. Here are a couple of them, with the two I just mentioned. The one I just mentioned would be an overflow exception, kind of detected by the microprocessor. If you take my assembly language class next semester, you'll see exactly how that works. It's a bit overflow type thing. And then this divide by zero exception, it's the microprocessor is able to recognize when the divisor in a divide instruction is 0, and it's akin to an overflow exception, because of course if you divide anything by 0, it's infinity, which of course is too big of a number for the microprocessor to be able to store. So these are some methods that might throw an exception. When you're converting a string to a decimal, you can have a format exception, which is where they typed in some letters instead of some numbers, or the string of the number that you're trying to convert is just too big. Same with integer stuffing an integer that's too big into 32 bits. It can be overflow, or again, if you try to type in some letters. Parsing a string into a decimal number, same thing. And if for example you're trying to read in a date or a time, and you type in something that's not a date, that doesn't look like a date, that can't convert to a date or a time, it's got to have you can have some slashes in there to separate months, but the month has got to be between 1 and 12. The day has got to be between 1 and the number of days that are allowed for that month, and year, and so on. So that would not ever really cause an overflow exception, but it could certainly cause a format exception. And we also reviewed, because you've seen this before, how to display a message box. And the text portion of the message box is what you see right here. And the caption, which is optional, that's indicated by these square brackets. That caption is what you see right here. And so that's what you're seeing down here. This is the text, and this is the caption. And then we reviewed try catch. That's how you catch exceptions. Try means try to execute this code. If you're successful, that's great. Don't have to do anything more. It's executed already. If you try to execute some code and you're doing something, you do something which causes an exception, this can cause an exception, which we discussed already. If that happens, then it does not complete the statement. It does not complete the execution of the statement, because it would cause an error. Instead, it jumps down to the catch portion and executes the catch portion. So it's like a trap. It actually catches an error just before it would have occurred. And if it were allowed to continue and execute, you'd end up with your code, you'd bomb, and you'd see this thing appear. So here's an example. Somebody tries to type in a decimal number, and they type in some X's. This error appears. And so this is the syntax for try catch. You got a try statement and a bunch of statements inside of between the curly braces, and then you have this catch statement. This is actually optional. You don't have to have this thing, but if you do, then this specifies the type of exception it specifies what type of exception this catch statement is intended to catch. And you can have more than one catch statement, because you can have this hierarchy of exceptions, which we saw back here. This hierarchy of exceptions here. Two common properties for all exceptions. So So you have this this exception class thing is intended to grab. Okay, exception class is actually this or this or something, and so it's a class. You're defining a class, or you're defining an object which is of this class type, and then this is the name of the object. You just have any name. We often use just EX. And then these are the statements to execute when there is the exception. And EX has got a couple properties here, got a couple of nice properties. One of them is EX.message, the message property, and that displays out the actual message that was returned, which is basically this thing here. That's the message. And then you can also have EX.stackTrace. And the EX, of course, is the object name. That's what you name it up here. And stackTrace will list all the methods that were called just before the exception occurred. So in that would be, oh, that's not shown here. And then you also have this method, EX method, which will tell you the type of the current exception, whether it's an arithmetic exception or overflow or whatever. So here we've exception class. This is the name of the object. It's a class, and we're using the message, or display out the message. We display out the type, and the type is, it's something you want to do toString because it's not in a string format yet. And then the stack trace, which displays out the list of methods that were called that led up to that exception. And so this is an example here. So this is the message. This is the get type. This is the type. It's a format exception. And then this right here is the stack trace. And so what this is saying is that the thing that actually caused the exception to occur was you were trying to convert a string to a number. And that was down inside the parse decimal. You're trying to parse a string into a decimal number, and that was called by probably this convert thing. And so these are all inside this. So these are all inside this, and this is probably your program code. Convert to decimal. So we're talking about this, convert to decimal. So this is the code you see, but inside this to decimal method, inside there is these other two methods. This is a method that's inside internally. You don't see it or know of it unless you're looking at this. And so you see this, and you also see, you see this, because that's your code. And then you also see this. This is the method that contains the code that you wrote. So we see that this is actually sort of like code you wrote also. And it's the button calculate _ click. It's the click event handler for the calculate button. And that's something that you wrote. That would be the name of this is all inside of a method, and it's this method, the button calculate method. And then the button calculate method is inside the form1.cs file on line 23. So that's why they say it's a stack trace. It sort of pops you back up to where the actual line of code is that caused it. And so here we have a bunch of catches, and so this first it's going to check to see if it's this, and if it's not, it checks to see if it's this, and if it's not, it checks to see this, and then this finally I don't really understand why you have I mean, I've never finally is always executed. Finally is executed whether or not you do try, or whether or not it's one of these catches that occurs. But I suppose what can happen is inside here you might set some variable. Inside you might set some variable, and then this finally will look at that. But you know, after this is all done, the code continues down here executing it. So anyway, so here's an example of catching two separate exceptions. And so you know, you might have, okay, so we're trying to do this conversion here, or no, we're reading in a monthly investment, and we're reading in an interest rate, and we're reading in a number of years, some number of years, and we're trying to convert the monthly investment to a decimal number and store it in this variable here. And then after that, we're trying to read the interest rate stored into a decimal number, which is here. And then lastly, we're trying to read in a number of years, and it's converted to an integer and stored into an integer right here. So the types of exceptions that can occur is, first of all, we can have a format exception, and that can be caused by if you type some letters in there instead of some numbers or some nutty thing like that. And so that's the first thing it looks for. If you formatted the number properly, then that would not have caused the exception. So we aren't going to do this. Maybe you typed in a number that's too big, and you know, and that could be like the number of years. Maybe you type in some integer for a number of years that's way too big, or some crazy thing like that, and that would be caught here. Or maybe there's some other kind of exception that you didn't account for. Now, I cannot offhand think of any other type of exception that this code could cause if you did something wrong. But you want your code to be robust, so we throw in this last thing here, which is simply which basically catches all the other kinds of exceptions that are possible that are not format exceptions and are not overflow exceptions. And so here you want to have this EX variable, and so you actually want to display out that message and display out the type and so on. So that's this hierarchy of exceptions. And we can actually throw exceptions ourselves in the code for testing or whatever. We define our own. And that would be some sort of business rule. So here our business rule is that we aren't going to deal with negative interest rates. It's possible to have negative interest rates. Like the longer you leave your money in there, the less there is. And so you might decide that you want to throw an exception if that occurs. You may decide you want to handle it that way. You know, you're a purist. You know, you like this exception thing. You like using try catches or whatever. So you can create your own set of exceptions that will be thrown should the user type in something that's funny. So here's an example of throwing an exception. You can rethrow exceptions. So here's a code for this future value application that we talk about in this textbook. And there's a bunch of, so you just throw your code in here, which is fine. And then you have a bunch of exceptions. You catch all the kinds of exceptions that can occur next. So this is the try part, this is the catch part. You might have some finally after that. And this is something that code for, so this comes afterwards, I guess. All right. So that's one way of handling erroneous code entered in by the user. The other way of handling erroneous code is to have input validation. And with input validation, you don't take advantage of the try-catch, exception catching features of C#. You actually make your code smart enough to test it without using try-catches. And as I mentioned before, back in the old days, that was the only way to do it. You put in all this input validation because you don't want your code to bomb, and so that's how we handled it. So here, to do that, we use the try parse method. And the try parse is a method that's available for all these different data types. This is like the decimal class. It's a class called decimal, and try parse. What try parse does, of course, is it reads the first argument of the try parse method is the text that you're trying to convert to a number. In this case, it's a decimal number. And so it looks at the text and it looks, will that text convert to a decimal? If it will convert to a decimal, it goes ahead and converts it and sticks the result in the second argument, which is a call by reference. And this whole method here will return a true. It's this whole method here. Let me, can I erase this? So this is the method here. It's the method. And this method is going to return a true or a false, depending on whether this thing is convertible. If this thing can be converted. If it can be converted into this, then this whole method returns a true. Well, if this method returns a true, then this makes it false. And so the way this if works is if it's not convertible, then it's going to display this message. If it is convertible, then it's going to stick the value into this monthly investment variable, and it'll take the else part and there is no else part. So it doesn't need to be an else part. Else part, it would continue. No, I guess it would need an else part because you want this to because after this executes, you don't want to go down here because that's where you go if the conversion was successful. And so here's code that checks for entry for a valid range, and here we're checking if the monthly investment is less than or equal to 0. Then we got this error message saying, you know, it's got to be greater than 0. If the monthly investment is greater than 1,000 in this particular code, we're only going to handle monthly investments up to 1,000. If it's greater than 1,000, it's going to execute this code. And this is a method which checks for a required field. And by a required field, all we're saying is that you got to enter something into this text box. If you don't enter something into the text box, then that's an error. So all you have to do is check to see if it's not blank. If it is blank, then you want to display out this error message. And so this is just a method that we write. And this does the check for us. So we have this nice method here that returns a true or a false, either returns false or it returns true, based on whether see, what is this? How does this work now? Text box string name. What does the name do? Oh. Okay, all we're doing is we're passing in the name of the variable, and it's just the code. It wouldn't have to be the name of the variable. Really, what we're doing is we're testing this text box, which is a control sitting on your form, and we're checking to see if it's a decimal value. So inside here, we actually test it by using try parse, and if it is if it's convertible, then this thing is going to return true, which is this method here will return a true because it's Boolean. It's going to return a true or it's going to return a false. This checks for a range, and we're checking to see you know, if it's in a range. And actually, in this method, we actually pass it the range, the minimum value and the maximum value. And so down in here, we actually test if the number, the number's got to be, you know, if the number is less than the minimum value or the number is greater than the maximum value, then that's an error. So this thing displays out the error message and returns false. So this thing returns a false. If this is not true, that means the number is in range and it's going to return true. Now, the reason we don't need to have an else is because once a return is hit, once a return is executed, then nothing else is executed inside this method. It jumps out. This returns, this says return a value to this method that was called, and you don't need to put anything else afterwards. So if it makes it all the way, if it makes it past this, then we know that it must be in range, and so it returns a true. So when you're writing your homework assignment, first thing you're going to do is write a bunch of these methods. You're going to write a within range method. You're going to write an is decimal method. You're going to write an is present method. You're going to write these methods, and then you're going to use them like this, where where, you know, instead of using a try catch, you're going to check these things in succession. First, you're going to check to see if the guy typed in something, and so you're going to use your is present. First, you're going to check to see if he typed in something, and if this returns true, then great. Let's move on to the next one. If it's false, then this is the sort of the error message. This monthly investment is like the error message is going to display out. Is present is this thing. So this is the monthly investment, and so it's going to say monthly investment is a required field. Monthly investment is a required field. So if this is true, okay, so if this is false, if this ends up being false, then because we're using a double ampersand, it quits. Because if this is false, and we're talking about anding a bunch of Boolean variables together, or anding a bunch of true falses together, if we're anding and one of them is false, then the whole thing is going to be false. If this ends up being true, then we don't know enough yet, so we got to look at the next one, and the text checks to see if it's a decimal value that was entered in. It's present. In other words, it's not empty, so we can test for decimal value. And if the decimal value is true, then we still don't know enough yet, so we got to test this last one, and this last one tests to see if it's in range. So you can see that we're still honoring this hierarchy here. First, we see if there's something typed in there. Then we see if it's an actual number that's typed in there. And then we see if the number that's typed in there is within range. If any of these is false along the way, then we stop. I mean, it makes sense. If there's nothing present, for sure, it doesn't make any sense to test if it's decimal because it's nothing. And it certainly doesn't make any sense to test if it's in range because it's nothing. So that's how we test. Instead of using try catches, we actually write code to test. So another way to do it, this is just another way to do it, you remember I said that once it encounters a return statement, it quits. So another way to do it is not to and all these things together and have, not to and them all together. Just first check to see if it's present. If it's not present, just return false and you're done. If it is present, then this is going to be skipped. And test this one. If it's not a decimal number, then you're done. Just return false and then that's it. Oh, if it is a decimal number, then this thing is skipped. And we just then we test to see if it's in range. If it's not in range, then we just return false and that's it. And then here we go on and we test if the interest rate that the guy typed in is the same. So up here we're validating the monthly investment text box, and here we're validating the interest rate text box. And if it makes it all the way down at the bottom here, then that means that none of these were taken. None of these were executed. If none of these were executed, that means it must be present, it must be decimal, it must be within range. That's monthly investment. And it must be, then the interest rate must be present. The guy must have typed something in. The guy must have, and in this one, the guy must have typed in a decimal number, which is great. And this final test is the guy must have typed in something that's in range. So that's great. So none of these return falses will be taken because everything was cool. And then it simply returns a true. Here we're really taking it to the max here. We're just anding all these things together. This one is present, this one is its decimal number, it's within range, and the interest rate is present, the interest rate is a decimal number, and the interest rate is within range. And here we include the range values. These are the range values. Up here, this is just sort of some text to let us know which which thing we're testing. You notice it's the same is present. We're using this method twice, once here and once here. We're using the is decimal twice, once here and once here, and we're using the is within range twice also, and it's got parameters. So the first time we use the is within range, we're checking if something is between 1 and 1,000. The second time we use that same method, where we're testing if something is between 1 and 20. And these are dialog boxes, or this is the form for entering in the monthly investment, the yearly interest, and the number of years. And you notice the guy did not type in a yearly interest, so the is present error message is displayed. This is what happens if you type in a monthly investment that's present, but it's not a decimal value. And then this is what's displayed out if the guy typed in something for a monthly investment. In fact, he typed in a decimal value for the monthly investment, but he didn't type in a decimal value that was within this range. And so this one gets executed, or this dialog box appears. And then there's some other kind of exception where an unknown error has occurred. It's just a plain old system exception. This is where it happened. It happened in the future value.form1 button calculate click event handler. And I don't know, all kinds of errors can occur. There's a memory hardware error. I don't know. There's exceptions that are triggered that happen rarely. They're obscure, and if you're using exception handling, well, in fact, you would want to have something like this in there, even if you're doing data validation. You would still want to catch for unknown errors. Your data validation can't check for unknown errors. It's also kind of difficult for your data validation to check for these arithmetic exceptions also. I mean, how do you write, well, I guess range can be, that's what this, if you're testing to make sure numbers don't get too big, if you're testing to see if you don't have an overflow error, that's kind of what this, that's what the is within range tests. So if you have something like this, you'll never have an overflow error. Although, wait a second. You can still have an overflow error. Why? Because in this code, if this number, let me erase this. In the code here, if the guy types in a number that's too big, then if the guy types in a number that's too big, oh, if the guy types in a number that's too big, then this is not going to work. That's right. If a guy types in a year that's too big, then your range calculation will not work because it's too big of a number for you to do any calculations. If this number is too big, then you don't end up, there's nothing here because you couldn't convert it. Nothing here, you couldn't convert it. So anyway, just keep that in mind. So this is code for the future valuation. Is valid data is this thing here. All right, now this is really fancy. Why? Because this is a great big huge O Boolean expression that's going to evaluate to either true or false. It's either true that monthly investment is present and monthly investment is decimal and monthly investment is within range. And text interest rate is present, text interest rate is decimal, and interest rate is within range. And the years typed in is present, the years typed in is an integer, and the years typed in is within range. We're doing and, and so it's going to, the whole thing is going to end up being either true or false. If just one of these is false, then the whole thing is going to be false. And this is a Boolean variable, this is the Boolean method, and so we're going to return a Boolean value. We're going to return either true or false, and this whole big thing in the circle here is going to evaluate to either true or false. And so this return statement is going to return the evaluation of this big long expression here. It's going to return true or false. So this would be considered elegant by computer science purists because it's just one statement. It's one return statement. And this whole big expression here evaluates to either true or false. And inside this is present is going to display out the error messages if it's necessary. So let's say it's not present. Well, this thing is going to execute, which executes this down here, which is going to do something. It's either going to return false or true. If it returns false, then this thing ends up being false. And if this thing is false, then the rest of the stuff doesn't even have to be executed. It's going to return a false, and so this returns a false, in which case this is going to be false. So if the data is not valid, the if the data is not valid, then the error messages are going to come from way down here. And this catches the exception, an unknown error has occurred. However, as we just discussed, it's still possible to have this code, and you can this code is not gonna detect an overflow error. You know, if you type in you want to type in a year, and you type in a bunch of digits that's bigger than 2 to the 31st power, which is bigger than 10 to the 20th power or something, 22nd power or whatever it is. It's yeah. So anyway, this is the is decimal. It's going to return true or false. This is the is integer 2, 32-bit integer. It's going to return true or false. Within range, it's going to return true or false. It inputs the range. And this is the calculate future value calculation. So if everything is valid, then somewhere it calculates here's where it calculates the So here we're taking the monthly investment and we're converting it to decimal. And okay, so okay, so here we're using triparse. This is interesting. We're using triparse, and we're getting a number out, but we're not going to use it. Okay, so we're only using triparse to see if this is parsable. You got that? So we're only using the part of the method which will return true or false if it in fact is parsable. Now, if it's parsable, it's going to return what the parse value is, but we aren't going to use it down here, so we don't even do anything with number with this value coming back. You know, so we don't use it any place. We just return basically if it's parsable or not, and then we do the but back up here we don't need triparse. If it passes this returns true, then we know it's parsable. You know, this is parsable, this is parsable, this is parsable. So we know that. So then we don't have to do anything. We just convert, and we just convert, and we just convert. All right, so now that we're done with that, been through that twice. So it's 242. I don't need to. We've sort of beat this to death already, so you should be able to write the programs to do these two things. You know, you want to check to see if it's parsable. Let me see. Do I have a which browser am I using? Let me use this browser here. It's this one, this one, this one. Let me do this pen thing. Hope it works. So you need to do, okay, for exception handling part, you need to, you know, you can use try catch, convert that to, this is all are these integers? Well, they don't have to be integers. It can be decimal numbers. This doesn't work when you're in hand mode. Yeah, you still need to check to see if this is a valid operator, times, plus, minus, divide by. And then you want to test to see if this is a valid operator, and you pop the result in here. And these are errors that you would output if you're doing exception handling. And then I'd like you to hand in a second project where you do the same thing, but you're doing data validation instead. So checking for this, a valid operator is going to be the same as up here, but here you do use the techniques that we talked about in the second half of the slides to make sure that this is. So use try parse. Here you use try parse, and you use try parse down in the is present. You have to have an is present. You have to have an is decimal, or is present, is decimal, and the third one is in range. I don't know. Oh, here is valid data. Between these two, I guess we're doing integers. No, we're not. We're doing decimals. Okay. So you want to make an is present, is decimal, and is within range. Format exception, overflow exception, divide by zero exception. For exception handlers. And then here, you want to do this. You still want to do a try catch, although you can, in fact, yes, do it this way. If you're doing division, I want you to test to see if this is 0 or not. So you can catch a divide by 0 by your code. Need any hints on that, just let me know, I'll give you a hint on it. Make sure its data is validated properly. All right, are there any questions? All right, so I will. So I think I'm going to close it up here. If anybody has any problems, you can talk to me, and I can sort of meet with you individually, and we can get through this that way. Shut this off. Where is the? Where is my? What happened? Zoom. Is this it? All right, so I guess I'm not sharing anymore. No more questions. Thanks for watching. Uh-oh. I hope this is working.